What you see here is a list of the videos that I normally assign my online students to watch. The Marginal Revolution University videos for this section are pretty good. And in general, what we're going to look for is building a model of the entire macroeconomy that uses the supply and demand curves similar to what you've done before, but that goes a little bit deeper and broader at the same time. In other words, we're going to look at the entire economy instead of any particular industry. This is a list of the videos that are on marginal revolution. So chapter 13, economic growth is not a smooth process. Right? We've looked at how the economy is growing over time. And what we can say is that it's been growing at a rate of about 3.2% a year. But we recall that, if we look at over time, how this has affected real GDP, right? We understand that there have been times where the economy is growing faster than that and slower than that. This is called the business cycle. Time periods where the economy is growing faster than 3.2% are called expansionary periods. Time periods where it's growing slower are called recessionary periods. And we see that that the growth rates have varied between negative 5% over some period of time. It's actually, the economy has gotten less well off, to periods of time of 8% economic growth year over year. Okay. Now, this fluctuation has to be related to what we're going to talk about in terms of the overall economy. So we can move this over to a model that talks about the whole economy. The whole economy has a supply curve of stuff. A supply curve of stuff. We're going to call that our long-run aggregate supply curve. Okay? This is going to be our long-run aggregate supply curve, and to that we're going to add an aggregate demand curve and a short-run aggregate supply curve. And we will put on our axes the percentage change in price, which we can signify as pi for inflation, and the percentage change in output, or similarly, the percentage change in real GDP. And we can say that real GDP trends at about 3.2%. So we're going to describe how these axes are not in absolute terms, but in dynamic terms instead. I'll come back to that in a minute. Next slide. Okay. So again, we have these business fluctuations where there are time periods where the economy is growing faster or slower. Among the things that we're interested in understanding is, well, why are there business cycles? Why is it that sometimes the economy is growing faster or slower? There's been a lot of debate about why this has happened, and we're going to get into some of those issues shortly. Again, a recession is when the economy is down. An expansion is when the economy is up. So let's go to the next slide. Before we do, this link will take you to the Federal Reserve Economics or Education Database or something like that. It's called FRED, F-R-E-D. It is produced by the Federal Reserve Bank of St. Louis. Did you know that there was more than one Federal Reserve Bank? There's a whole bunch of them. Anybody got $1 on them? Anybody? As many of you that have $1 on you, take it out. I think it has to be $1 though, not a $5. No dollars?
I got one.
All right. Inside the circle, there's a letter. Do you see the letter inside your circle?
No.
G, L, and around the outside of the circle, it has the name of a bank.
Chicago.
Chicago.
San Francisco.
San Francisco. Okay, so there are Federal Reserve banks all around the country. I think there's 12 of them altogether. All right. So those are banks that are banks for banks. We'll understand a little bit more about the Federal Reserve going forward, but the one in St. Louis helps produce all this data. If you click on the link, you can get updated data, right? And more measures than what we're going to talk about today. Okay, so this graph is showing real GDP growth rate trended over time. And what you can see is that sometimes it's up and sometimes it's down. There are gray bars on the graph. Those gray bars indicate time periods of recession. What you'll notice is the blue line goes down close to those gray bars, right? That economic output is decreasing during recessions. That's what we mean by a recession. You'll also see the average growth rate that they identify as 3.2%. That's why I say that the average growth rate is 3.2%. We can also show, like they do, right, 3.2% in terms of time. We can say what the growth rate is each year. 1 year it's 5%, 1 year it's 1%, 1 year it's 7%, and so on and so forth. And that's what the jagged line is that you're observing on the graph. During the down time periods, that's when they turn shaded gray. So there are multiple different ways to display similar data. When you do your GDP project with the map, you're going to create this graph for the country and state pair that you've been assigned. All right, this graph is also showing real GDP over time. Notice it's showing from 1950 all the way to 2015 and beyond. What's not on here?
2021.
Yeah, the pandemic is not on here. What did it look like during the pandemic? The real gross domestic product took a dive during that. So if you were to click through and find this data yourself on Fred, you'd see that. So then in this section, we're talking about recessions and why they are of concern to policymakers and the public. And in particular, unemployment typically increases. When unemployment increases, unemployment leads to social and political unrest. And it can lead to political revolution. During the Great Depression, the relevant alternatives to dealing with the problem of the recession, the Great Depression, were either let's overthrow the government and have fascism, or let's overthrow the government and have communism. Now, I don't want to say that either of those is bad per se. Well, I kind of do, but, right? That's irrelevant. What's relevant here is that the people who were the elites in these societies at the time did not want to see their position as elites threatened, and so they did not want to see social overthrow or political overthrow. They wanted to maintain their position as elites within those societies. So rather than just letting the Depression ride itself out, there was a strong incentive to use their power to do something. And my understanding from public choice economics is the reason why people use power to do something is so that they can keep their power, primarily. Okay. The next page shows the civilian unemployment rate and how it goes up during a recession. Again, those gray bars are recessions, and we're looking at unemployment. We did a whole section on unemployment, and you see how during the gray bars, when there is a recession, when production goes down, unemployment goes up. And it happens for each of these time periods. And what we see here is 2020, just a tick mark at the beginning of 2020. Right? When we hit the bottom of the pandemic, right, they actually had to shrink the scale down because the line went too far up. Right? The unemployment rate went so high that it couldn't even fit on this graph anymore. So they had to change the scale. Okay, now, John Maynard Keynes, the son of an economist, somebody who had a lot of political influence. He spoke with authority, with confidence. I might try to find a video of him actually speaking in public so you can get an idea of his approach, of his presence. Very charismatic individual. And he was an economist in Great Britain during the Great Depression. And he wrote this book called The General Theory, trying to explain how we could get out of the Great Depression. And again, his primary motivation was to avoid totalitarian overthrow. He wanted to find ways out of the Great Depression to prevent political unrest. And that's kind of how macroeconomics was born. There's always been the study of capital, of employment, of some study of economic growth, but this idea that there's an entire separate course or field of study that is macroeconomics didn't really come to be born until after what we call the Keynesian revolution in the 1940s and 50s. Keynes wrote his book in the 1930s. It's important that you understand that ideas have consequences in the way that we live our lives. These are not just two obscure scholars, Keynes and then Hayek, about whom you might need to know something. These people and their ideas have had a major impact on the way that policymakers understand the world around us and how they shape policies. F.A. Hayek was an economist, came out of Austria. He studied under a guy named Wieser, who studied under a guy named Karl Menger, who is often referred to as the founder of Austrian economics. Many of the professors here at Ball State have some grounding in or interest in the study of Austrian economics. Hayek was also in England at the time. They actually worked air raids together, trying to, blow whistles to get people to close their curtains to hide the lights so that their houses wouldn't get hit by bombs from German bombers. Okay, he was in England at the time too. He was concerned that Keynes's approach to dealing with the Great Depression, this cure for the Great Depression, he thought it might be worse than the disease itself of the Great Depression. And Hayek tried to look beyond how to get out of the Depression, try to understand, well, how did we get into the Depression in the first place? Amongst other ideas, the Austrians tend to believe that intervention into markets by government or the Federal Reserve tends to be a source of political and economic instability. That when the government changes the amount of money in supply, that can actually cause a recession, or at least a boom in the short run, which then in the long run could lead to a recession. Oftentimes we're tempted to believe, oh, what was going wrong here, and why wasn't it doing as well as it was before? But if you ride a roller coaster before, you know that first you have to go up before you can come down. And so one of Hayek's ideas was that the recession was caused by the overexpansion. In the same way that we've talked in this class about studying for econ and finance, right? And you study an all-nighter because you pull an all-nighter because there's an exam in both classes. You overextend yourself. That means you have to take a nap later on. You can have an expansionary period, doing more than normal, but you're going to have to pay for it later on by taking a nap, by doing less than normal. The question is, how do we do normal, and is it important to stay on normal and to avoid these overexpansions and recessions? My intellectual debate between Keynes and Hayek is well recognized as being an important public debate that has lasted almost 100 years now. How prescient is it? During the last recession, a lot of people started debating the ideas of Hayek and Keynes again, comparing them to one another, trying to understand what caused the 2007 recession. Was it a more Keynesian story, or was it a more Hayekian story? And the answer is maybe somewhere in between. But the ideas were so prescient, so relevant to that time period, that there were even rap videos being made about it. And I'm going to give you links to a couple of those rap videos. They're a little bit long, they're a little bit corny, but they're actually quite well done. Pretty high level of production on those videos. Other people also contributed a lot of important ideas to this big, broader debate about macroeconomics. Among them is Milton Friedman, who we've already talked about, right? Milton Friedman said what? Inflation is always and everywhere a monetary phenomenon. You recall that? Okay. So Milton Friedman also contributes to this debate. And there are others as well. Okay. And sometimes you just got to go a little bit closer. All right. So to understand booms and recessions, we're going to develop this model of aggregate demand and aggregate supply with three curves. I've drawn them already. You have your aggregate demand curve that's downward sloping. You have your long run aggregate supply curve, which is straight up and downy. We call that perfectly inelastic, straight up and downy. And then we have a short run aggregate supply curve. We're going to build this model step by step, including each of the parts, and explaining why they come from. This model shows how unexpected disturbances or shocks could temporarily increase or decrease the rate of economic growth. A shock, you'll remember, is something that comes from outside of the model and changes something inside of the model. It's unexpected, typically. So first we will start by noticing that oftentimes when this model is developed, we begin with what is called the GDP factory. It looks like we're talking about a GDP factory. In other words, in this model of the macroeconomy, I should label it, or I'll get points taken off from Professor Snow. This is the market for all goods and services. All goods and services, right? This is when the little girl goes to see Santa Claus and says, I want to have all the toys. Just like when we're counting up GDP, we want to talk about the market for all goods and services. When we talk about this, and we talk about output, we're talking about GDP. But GDP is not a thing that you consume. You don't go to the store and say, hi, I'd like 2 GDPs, please. Right? I need to buy a new pair of GDPs. My old ones are wearing out. Right? I'd like some nice new GDPs to go with my dress. Right? No, we don't do that sort of thing. We don't buy GDPs. We buy individual specific things. The market for all goods and services is aggregating all of the things. It's all of the things together, not any specific thing. Oftentimes when students are introduced to this model, and then I ask them to draw a graph of a particular market, like the market for shoes, right, which has price and quantity on the axes, oftentimes the student will be tempted to draw not only a supply curve and a demand curve, but also a long run aggregate demand curve. No, we only draw the long run aggregate supply curve when we're talking about the market for all goods and services, not for any particular market. Okay? We limit the use of this to when we're talking about everything. Why? Why? And what do we even mean by this? Well, this graph and this line on the graph, this long run aggregate supply curve, is really similar to the production possibility frontier. We're talking about fishes and coconuts, for example. What this line represents is the maximum sustainable level of output for all productive resources within an economy. How much stuff can we get next year? And it doesn't matter whether it's relatively more fishes or relatively more coconuts. It's still adding up just to stuff. It could be that one day a wind blows a whole bunch of the coconuts into the lagoon, and as a result, you can't have as many coconuts, but something has fed the fishes, more coconuts. So now you have more fishes. So the amount of coconuts decreases, the amount of fishes increases. You have, on net, the same amount of GDP as you would have had before. And your overall personal satisfaction is relatively similar. So this line is describing the long run, sustainable amount of output. However, this is static. It's talking about the maximum sustainable level of output at one point in time. What we want to think about is not just the static point of view, but also the dynamic point of view. So it's helpful to think back to the solo model that we explored last week, where we have capital and output, and we have the y equals the square root of k kind of model. Right? At any given point in time, we have a certain amount of capital and a certain amount of output. What could cause the amount of capital and output to increase? Or, let me say it this way, what could cause the amount of output to increase holding the level of capital constant? Technological change. That's what came in the second half of that chapter. That a technological change would cause the overall production function to shift up. To show that in our production possibility frontier, we would have to say, okay, every year, Crusoe's net gets better and better. He has a better net for collecting fishes and coconuts. So every year he's able to collect more fishes and coconuts. And every year it's increasing. On this graph, we're not going to show the long-run aggregate supply curve shifting. Instead, we're going to say, how fast is it shifting? Not where is it, but how fast is it shifting? Not even how fast is it going, but how fast is it shifting? That's like acceleration. Like when you're driving and going 40 miles an hour, and then you speed up to 80 miles an hour, what's your rate of acceleration? And that's kind of what we're trying to get at here, is how fast is the economy growing? This point on our curve is a description of how fast the economy is growing in terms of all of the stuff that we can make. So it's similar to this curve, but it's showing the rate of change every year of growth. It's similar to this curve, but it's showing the rate of change every year. It's showing the same thing as this, that the economy is growing at a certain rate. Are there any questions? It's a complex idea. Right? And it's harder to show rates, it's harder to think about rates than it is just basic absolute numbers, but I think you're up to it. Okay. When thinking about this model, because the long-run aggregate supply curve is describing to us the maximum sustainable level of output, anytime that the economy, for any reason, is to the right of the long-run aggregate supply curve, suppose we find a new equilibrium over here. And I'm going to show how we do that in a minute. Suppose we find ourselves to the right. That means that we are overheated. We're pulling an all-nighter. Anytime that the economy is, for some reason, to the left of our long-run aggregate supply curve, that means that we are taking a nap. We are in a recession. That means that this green line is home. That's our goal. The short run and aggregate supply curve and the aggregate demand curve can intersect elsewhere. They can intersect over here, for example. And these two will be in equilibrium with one another. But we're going to say that this whole economy is not in equilibrium until, for some reason, we get back to somewhere along the long-run aggregate supply curve. That could happen due to a shifting back of short and aggregate supply, or it could have to do with the shift of the aggregate demand curve, and then we're back at home again. But we're only happy, the economy is only in equilibrium when we're back on our maximum sustainable level of output. When we are to the left of the long-run aggregate supply curve, we say we are in a recession. When in a recession, we don't like it because there's unemployment. But there's not only unemployment of people. It's not only you that becomes unemployed. If you're a worker and you become unemployed, the machine that you used when you were at work is now also unemployed because there's nobody using it. Right? Is that a problem? Well, not as much of a problem as the individual, the human being unemployed, except for this. If you plan on growing your business, right? Like the pizza shop, you plan on growing your business, and so you buy 3 new ovens. But then there's a recession and nobody wants to buy pizzas. All of the resources that went into building those ovens, the time of the workers, the metal, the technology, all of the resources that went into building those ovens could have gone into building something else that people actually did want, even in a recession. There has been an investment into those resources, into those units of production, those units of capital. Those resources could have been used to do something else instead. And apparently, we don't want more ovens because we're not buying pizzas. So then, whatever other allocation of those resources would have been wanted by people would have been better. So there has been a mal investment. And mal means bad. Okay, so here's our production possibility frontier. Right? Full employment is when we're on the line. Inside the frontier, some resources are not being employed. We could do more. What about today? Many people are producing inside of the production possibility frontier. The aggregate demand curve is like the demand for all of the things, but we build it from the quantity theory of money. The idea is this. Miller and Friedman had this model, M times V equals P times Y. P times Y, the general price level times GDP, is nominal GDP. Nominal spending. All of the things that were made and purchased and multiplied by the price of the average thing, that gives us total nominal spending for the economy. We're going to say that that is equal to the amount of money that is flowing through the economy multiplied by the rate at which money is flowing. Okay. Suppose you have a little fountain with some water in it, and the water comes out in like a little spurt, like the frog baby. The total flow of water is what we're interested in. So if the water comes spurting out faster, you need less water to get the same amount of flow. If you have more water, maybe more fountains, a bigger hole that the water comes out of, then you need less speed of water to have the same amount of water flowing. Do you follow? Okay. Now what we do with this overall equation, this also is equal to nominal spending. What we do with this equation is we apply something mathematically called the Euler theorem. All right, now you don't need to know it, you don't need to study it, you just need to know the result. The result is that when we try to think about the rate of change of each of these variables, they show this relationship. The percentage change in money plus the percentage change in velocity is equal to the percentage change in price plus the percentage change in output. When we look at the rate of change of each of these variables, they're no longer related by multiplication, they're related by addition. What I'm going to do is I'm going to use this variable, the percentage change in price, which is basically inflation, which we signify with the letter pi. And this variable, the percentage change in output, which is really the percentage change in real GDP, right? Percentage change in real GDP, or we could call it the real GDP growth rate. And notice these two variables are on the axes of our market for all goods and services. That's what we put on the axes for this big picture. Those variables then, these two are endogenous to the overall story. In the same way that when we drew graphs for markets for shoes or milkshakes, right, we had a demand curve and a supply curve, and we said that price and quantity were endogenous to the model. What happens if the price falls? Well, if the price falls, right, we are at a new price level, the quantity demanded increases, but the quantity supplied decreases without having some reason for shifting the supply or the demand curve. This is all we can say. We don't say that supply changed, we say that quantity supply changed as a result of a change in price. We don't say that demand changed, we say that quantity demanded changed as a result in price. The change was to an endogenous variable. If we want to shift either the supply curve or the demand curve, we have to have some sort of a shock based upon an exogenous variable. So we say, okay, what happens if income increases? If income increases, the demand curve shifts, and we wind up at a new higher quantity demanded and a higher price. That's an exogenous change. In the same way, in this model, we're looking at real GDP growth as one of the variables and inflation as the other variable that are endogenous to the model. But knowing that this is on the left-hand side of this equation, we can say that a change in the quantity of money or a change in velocity, these are the exogenous variables. And if there is a change in the amount of money or a change in the velocity of money, that will cause the aggregate demand curve to shift. So we move our aggregate demand curve based upon either a change in the quantity of money or a change in the velocity of money. Let's show this by itself. Let's isolate the aggregate demand curve for a minute. All right, I'll put inflation here, and I'll put real GDP growth here, and I'll just draw the aggregate demand curve. Suppose aggregate demand, which is a description of nominal spending, is 8%. That means that between this year and next year, everybody is going to spend about 8% more dollars. Does that mean they're going to buy 8% more stuff? No. Why not? Because there will have been some inflation. Right? Okay. So if nominal spending is 8%, that can be split between how much more actual stuff you're going to buy and how much money is going just to cover inflation. For example, we could find if the growth rate of the economy is 3%, we would find that the rate of inflation is 5%. And that would show up as 5 plus 3 equals 8. Similarly, if we know that the rate of inflation is only 2%, and nominal spending is changing by 8%, that would suggest that nominal spending is growing at, that real GDP is growing at 6%. The aggregate demand curve then is just the schedule showing the relationship between all possible combinations of inflation and real growth that add up to the same amount of nominal spending growth. Money supply, we're going to call that M. A dollar gets spent how many times? We call that V. Real goods and services is little y. The price level of all finished goods and services, I put little p, but I'm using pi on the graphs. M times V is the total amount of spent on final goods and services. P times Y is the price level times the real GDP. Okay, so both sides of this overall equation are equal to nominal GDP, as I've said. When looking at the growth rate, we get, and sometimes we put an arrow over each variable instead of percentage change. We just write arrow, which indicates percentage change. It's just a way of writing it. Nomenclature. And the aggregate demand curve focuses on the left-hand side of that equation when placed on a graph with P and Y as the axes, or pi and percentage change in real GDP growth. And it's good to remember that the variables on the axes are the endogenous variables for that model. And we talked about how that's similar to the supply and demand graph. If something other than price or quantity changes like income, then the whole demand curve shifts in the same way. If either inflation or output change, we move along the aggregate demand curve, we don't shift it. If something exogenous to the model changes, we shift the whole curve. In our model, we identify M, or the percentage change in money, and velocity as the exogenous variables that can shift the aggregate demand curve. Together, they add up to our spending growth. This is the nominal change in GDP. The nominal change in GDP is equal to the real change in GDP plus inflation. Okay, so if the rate of money growth is 6%, velocity is down by 3% because people shop less often, then real GDP growth is down 4%. Why? Because we're in a recession. So we find out what is the rate of inflation. We can say 6 minus 3 equals pi minus 4. What's pi then? Pi being inflation would be 7. So in this story, right, we're being told that velocity is down by 3%. right, that -3. What that means is velocity has slowed down. People are shopping less often. If we say that the Fed has produced new money and has increased the quantity of money by 6%, we're going to put it there. So M minus V, or plus V, but here V is negative, is equal to pi minus, and then we say real GDP growth is down by 4%. Okay, then we can discover what inflation rate is consistent with that. So we would have an aggregate demand curve where the nominal spending growth is 3%. And then we would ask ourselves, where are we along this curve? We find that the aggregate demand, the nominal GDP, okay, growth rate is 3%. And then we say, okay, when the economy is slowing down, when it's -4, so we can have 0 on this graph, we can also have -4, that would be a recession. It must be the case that what? Well, inflation has to add up to real GDP growth and add up to 3. What can we add to -4 to get 3? 7. So inflation must be 7%. This is sort of an example of how some of the homework questions like this might go. So the aggregate demand curve describes all possible combinations of real GDP growth and inflation consistent with a particular rate of nominal spending growth. And it's important that you notice that real growth can be negative. The aggregate demand curve also can shift. It can move. An increase in the growth rate of nominal GDP will shift the whole aggregate demand curve. So we can move from an aggregate demand, a nominal GDP growth rate of 3% to a nominal GDP growth rate of 8%. It can happen. Things can shift. Either an increase in the quantity of money or an increase in the velocity of money will cause the aggregate demand curve to shift to a new location. All right, so here's just another picture of how different combinations of inflation and real GDP growth add up to the same nominal GDP growth rate along different points of the same aggregate demand curve. We shift aggregate demand either by an increase in velocity or an increase in the money supply. That must flow either into a higher inflation rate or a higher growth rate. So then an increase in spending growth shifts the whole aggregate demand curve rightward, a decrease shifts the aggregate demand curve leftward. Here we see a shift in the aggregate demand curve. Either there was an increase in the amount of money or an increase in the amount of velocity that caused the aggregate demand curve to shift to the right. As a result, we moved from an aggregate demand curve of 5% nominal GDP spending to an aggregate demand curve of 7% nominal GDP growth. Okay, the long-run aggregate supply curve, I've shown how the production possibility frontier shows growth by shifting the frontier outward. The long-run aggregate supply curve shows, so just as in the Solo model, we discovered the rate of economic growth, that is going to be shown as a point or along the long-run aggregate supply curve. The idea here is that starting at some point on our long-run aggregate supply curve, that is similar to some point on our production possibility frontier. And what happens if we're on that curve somewhere and prices change? If the price level increases, where do we wind up? Well, here we are, and if the price level increases along this line, how does that affect our ability to be productive of things, of real things in the real world? The answer is changes in prices don't affect our ability to produce real stuff at all. Prices are merely the mechanism by which we coordinate our activities. The price level doesn't impact our actual ability to produce stuff. Our ability to produce stuff is dependent upon land, labor, capital, and entrepreneurial talent and technology. Right? The same things that we've talked about from the beginning of the semester. What makes us productive is our capital and our understanding and the things that we have available to use. That doesn't change when prices change. So there's this idea, sort of a money illusion. Every economy has a potential growth rate determined by increases in the stock of labor and capital and increases in productivity. That's all in the Solow model. That rate of growth, as determined by these real factors, is called the Solow growth rate. So our long-run aggregate supply curve is a vertical line at the Solow growth rate, and that's completely independent of the rate of inflation. It doesn't have anything to do with the price level. So it's perfectly inelastic with respect to inflation. The Solow growth curve is vertical because factors that cause economic growth, the accumulation of labor and physical capital, are unrelated to the rate of inflation. Inflation doesn't affect it. In other words, right, in the long run, inflation doesn't matter. Inflation can impact us in the short run, though. Solow growth is only about the long run. What kinds of things lead to economic growth? This is what we talked about in chapters 7 and 8. We said increases in productivity are very important. Machines, like capital, augment our labor and make labor more productive. New machines are changes in technology. The next slide is going to show us the number of hours per week typically women spent doing housework. It is decreasing. You can find this in Stephen Pinker's book, Enlightenment Now. The other lines show the introduction of new machines into households. They are increasing. The machines are substitutes for labor, making household workers more productive with every hour they work so that they had to work less. Okay, so on the left-hand axis, we see the number of hours of housework done per week. That's this big, long line starting at the top and going down. How many hours of housework did the typical housewife do back in 1900? Roughly 60 hours of housework. Hopefully the menfolk helped some, but we haven't become egalitarian in that way yet. Okay, notice how many households, the percentage of households, had running water in 1890. About 15% of households. We take so much for granted. So much we take for granted. It wasn't until roughly, around 1930 that 50% of households had running water. Now, some of you know this. You've been to maybe the old homestead, maybe your grandparents' place, and there's still an outhouse in the backyard. Or maybe you've driven through parts of rural America and you've seen outhouses. Right? Why have an outhouse? Well, because there's no way to flush. You don't want that inside. Even if you've got running water to the inside, you still don't want it on the outside. As you do the factfulness stuff, right, and look at the 4 different levels of quality of life around the world, one of the major things that they notice is, does this household have running water, or do they have to walk to some well or some river to get their water every day? Okay, here's electricity. Electricity is introduced early around 1900. Notice, more households had electricity than running water for some period of time. That's interesting. You'll see this also in other places around the world today. In underdeveloped countries, oftentimes they have electricity before they have running water. Why? Because they want to watch TV, right? Or they want to charge their cell phones. Or which is more important? Which is more important to you? Which would you give up first, your smartphone or running water? Be an interesting test. Refrigerators are introduced here around 1920. Notice how quickly the refrigerator is adopted. Right? Much more quickly than running water. Why? Well, in part because most of those households that adopt the refrigerator already had electricity. What do you want to use electricity to do? Amongst the first things that you'd like to do is keep your beer cold. That's the first thing you do. That's what's in most of your refrigerators most of the time. Of course, beer didn't necessarily have to be kept cold. Notice the introduction of the washing machine. Sort of slow at first, then it sort of takes off. Or I guess this is the washing machine. This is the vacuum cleaner. Here's the stove, here's the dishwasher, and the microwave. Notice how steep the adoption of microwaves is. Of course, back in the 1980s, when microwaves were first invented, the earliest microwaves cost around $4,000, and they were the size of an oven. Okay? Microwaves have gotten a lot less expensive. I'm pretty sure you can get one for 20 or 30 bucks today, and they take up a lot less space. Okay. The important thing here is that as adoption of these forms of capital have been brought into more and more American households, the number of hours of housework that are done, and it was typically by women throughout most of this time period, now, the opportunity cost of men doing the work or women doing the work is relatively similar. Men do more housework than they did in the past, but both people do less housework overall. Men do a larger share of housework than they did in the past. But overall, everybody's doing less housework. Why? Well, because the machines are doing it for them. Looking at the long-run aggregate supply curve, again, we started with the GDP factory idea. But remember, there is no such thing. We do not eat GDPs. You remember that every economy has a potential growth rate, not affected by inflation, instead mostly determined by the solo growth model type stuff. We draw our long and aggregate supply curve as a straight up and down line, perfectly inelastic, and we put it at the rate of economic growth for that overall society. We can combine our long run aggregate supply curve and our aggregate demand curve. When we do that, and where they intersect, that helps us to figure out what the inflation rate is. So on this model, we have a certain intersection of aggregate demand with aggregate supply, long-run aggregate supply. We have the growth rate, and if we have a spending rate, let's call it 8%, spending is 8%, and growth is 3.2%, it must be the case that inflation is 4.8%. Now, there are business fluctuations. We have this average growth of 3%, but shocks cause the actual rate of growth to shift back and forth. The question is, how do we show a shock in this model? There are shocks to the aggregate demand curve. But then there are also shocks to the long-run aggregate supply curve. Just because we're calling it long run doesn't mean it doesn't move. Long run has to do with capacity to produce. Capacity to produce. So we think about this in terms of, well, what can cause the capacity to produce to change? A hurricane can cause the capacity to produce to change. We can destroy a whole bunch of capital in a country through a hurricane, or through a war, or through a big disease, like a pandemic. Those can be described adequately, or at least to a certain degree, as a shift, not in aggregate demand, but instead as a shift in our long-run aggregate supply curve. We understand that as being similar to a shift in our production possibility frontier. Or we can put this back on our solo model. We understand that as a decrease in productive capital that then causes a decrease in our level of output. We have to rebuild that capital over time. So we could have some sort of a real shock that affects the overall economy, making us less productive in the short run. And that would be felt just like an aggregate demand style recession, but it's caused by a real factor instead. Again, a decrease in the supply of oil or an increase in the price of oil, amounting basically to the same thing, would also be well described as a real shock. So what do we have? We've talked about the solo growth rate. That is an economy's potential growth rate. The rate of economic growth that would occur given flexible prices and the existing real factors of production. Then we have the long-run aggregate supply curve, which is vertical, straight up and downy, perfectly inelastic at the solo growth rate. We have real shocks, which are rapid changes in economic conditions that will increase or diminish the productivity of capital and labor. Maybe the capital gets destroyed. Maybe a bunch of labor has to be sent home. Each of these things can happen. Next, we have a little bit more here about the long-run aggregate supply curve. And this is about transmissions. When there is a real shock in one part of the economy, it can affect the whole economy. For example, COVID-19 transmitted primarily or initially to hospitality, travel, education, healthcare, but then it transferred to everything. Right? Initially, restaurants shut down. That caused a reverberation, though, later on in grocery stores. Maybe one of the first shocks was to toilet paper. Right? You remember the toilet paper incidents. Those shocks do get reverberated and transmitted to the rest of the whole economy. You can think about it like throwing a rock into a pond. Right? The rock enters at one point, but then there are ripples throughout the entire pond. Eventually, the economy settles down. The pond becomes smooth again, as before you threw the rock in it, but that takes time. So there are lots of different mechanisms for transmitting and even amplifying a shock to the whole economy. Usually when you throw a rock into the pond, right, the waves get smaller over time. But there are ways within an economy that the waves can get bigger. I don't know, how can you talk about that? Maybe you can talk about throwing a cherry bomb into the pond and then it explodes after it goes under the water, right? There's amplification up here. Okay. So there are real shocks that, if they're negative, it shifts the long-run aggregate supply curve to the left, less growth. There's a positive shock that can move the long-run aggregate supply curve to the right, where there's less inflation and more growth. And if you haven't been, you should be drawing these graphs as I talk about them. That will really help you to do well. Okay. In the next slide, we see that reducing the solo growth rate results in an increase in the inflation rate. The sum of inflation and real growth must equal 10% for this dynamic aggregate demand curve. For the positive shock, real growth increases to 7% and the inflation rate must fall to 3%. So here we see our long-run aggregate supply curve. Notice that we have an aggregate demand curve defined by 10% nominal spending growth. There's going to be 10% more dollars spent within the year. If there is a negative shock to this economy, what we observe is a decrease in the growth rate, and at the same time, inflation goes up. If there is a positive shock, we see an increase in total output, and at the same time, inflation goes down. It seems to work pretty well to describe what's happening. As a bit of history, after Keynes wrote his initial stuff on macroeconomics, he only was identifying shocks to the aggregate demand curve. So when the United States in the 1970s had a period of recession where unemployment was higher than expected, where economic growth had slowed down some, the government thought that there must be some problem with aggregate demand. And in response, the government tried to boost aggregate demand. The difficulty was that the cause of that recession was not a shift in aggregate demand. The cause of that recession was a negative real shock, a shock to long-run aggregate supply. As a result, inflation went up and output went down. But then the government intervened and tried to boost aggregate demand. The result was that inflation just went up even more. But because the real factors contributing to the ability to be productive in the society had not changed, inflation just went up more and there was no change in total output. One economist described the attempt to boost the economy out of a real shock recession by increasing the quantity of money as pushing on a string. You lay a string on a table and push on it. Does the string move? No, it just bunches up. It just bunches up. And so the attempt to get out of the recession in the 70s and through the 70s really was ineffective because it was pushing on a string. It really frustrated President Nixon a lot. President Nixon ended up trying to pass all kinds of wage and price controls, which are price ceilings, you'll remember, which don't work, they just create more shortages. And so the entire economy was very frustrated through that time period. What kinds of things count as real shocks? Well, we've got agricultural shocks. So agricultural output depends on the quantity and quality of the inputs of capital and labor. Agriculture also depends on the weather. If farmers struggle, many other sectors of the economy suffer as well. And when weather fluctuates, so does output, and therefore so does GDP, especially in agricultural economies. In the early study of macroeconomics, agriculture made up a much larger share of overall economic activity. Remember, in the early 1900s, over 50% of the population lived on farms. So the major shocks to economies before the 1950s, basically, many of them were related to real shocks having to do with weather that caused changes to agriculture. So there's this relationship between weather and real GDP. Rainfall shocks and growth rate cause the growth rate of agricultural output to fluctuate. You can relate that to the growth of real GDP, and weather is directly related to actual GDP growth. Even today, some, but not as much as historically. Now, we're in America today, and that's an economy with a large manufacturing sector. Although more of our economy is shifting away from manufacturing and into service, in an economy with a large manufacturing sector, a reduction in the oil supply is a real shock to GDP. So oil and machines are complementary. They work with labor to produce output. When the supply of oil is reduced, capital and labor become less productive. So there was an OPEC oil shock that came in the 1970s. And the price of oil more than tripled in 2 years. Of course, the price of oil doubled this year too, didn't it? We've had similar shocks. Those have been mostly demand shocks rather than supply shocks. OPEC was this cartel of oil-producing companies that we talked about when I talked about the Persian Gulf War. We use oil in almost everything. So a shock to the oil industry hurts most American industries. In each of the last 6 U.S. recessions, the most recent one not included, there was a large increase in the price of oil just prior to or coincident with the onset of a recession. A 10% increase in the price of oil lowers the GDP growth rate for just over 2 years. So oil has a big impact on overall GDP, and right now the price of oil is up again. That can be contributing to the ongoing persistence of the current recession. Just like our other graphs, when we have a gray bar, that's a recession. This graph is showing that close to every recession, there's a big increase in the price of oil. Right around at or before the recession, there's a big jump in the price of oil most of the time. Even here, in the 2008 recession, there was a big jump in the price of oil before that recession. So wrapping up on the long-run aggregate supply curve, and we'll stop here for today. All right, there are these factors that can shift the long-run aggregate supply curve. There are negative shocks and there are positive shocks. The negative shocks move things left, the positive things move things right. There's bad weather or good weather. There's a higher price of oil, that's bad. Lower price of oil is good. There's a productivity slump or a technology slump. When new ideas are becoming produced less often or more often. That's kind of what I talked about last time. There could be higher taxes or more difficult regulations, or lower taxes and less difficult regulations. There is a disruption of productivity by war, earthquake, or, hello, pandemic. Or we can have a period of time with smooth production without disruption. Okay, so these slides were from actually going on 3.5 years ago now. The pandemic is something that Cowan and Tabarrok put in these slides 3.5 years ago. Cowan and Tabarrok understood the potential of a pandemic to be really problematic way before this current pandemic and built it into your textbook. It's not something that they just recently added in. Okay, next time we'll start with the idea of sticky wages, which I've already implied a few times before, and continue to build this big model of long-run aggregate supply, short-run aggregate supply, and aggregate demand. Thank you very much.